Hello, everyone, and welcome to today's segment of First in Focus. Today with us, we have Libby Kamen and FRC Team 1923, the MidKnight Inventors. They are an up-and-coming team, as quoted from Chief Delphi, have made huge strides towards becoming a heavyweight since 2015. Today's focus is on the MidKnight Inventor design style, as well as structuring for growth. Questions will be answered at the end, so feel free to drop any questions you might have in the Q&A box during the presentation. Now, without further ado, I'll hand it off to the MidKnight Inventors.
Yeah, thank you so much for having us. Oh, hey, Libby.
Hey, everyone. Oh, hey, Arna. Hi, my name is Libby Kamen, a mentor for Team 1923, the MidKnight Inventors. We're from West Windsor and Plainsboro, New Jersey, representing the West Windsor-Plainsboro Regional School District. So with me tonight to talk much more about design and sort of the strategic design as well as manipulator design specifically, I have Sid, who is one of our mechanical directors, and Arnav, who's one of our CAD directors. We are a very large team with also a very large directorship. So these are two of the awesome folks that make up our team leadership. I will get into that a little bit later, but mostly I'm going to let Sid and Arnav start off with their segments on design.
Cool. So I'm Arnav. I'm the CAD director, and
I'm Sid. I'm the mechanical director on the team, and we're here to talk to you about manipulator design and how we get through our design process. So Arnav, you want to take it away?
Cool. So awesome. So today, here's a quick overview of everything we're going to be talking about. So we're going to start with the basics of strategic design, you know, how we break down the game and analyze everything about it, and then define robot actions so that we really know what we want our robot to do. And then from there, we'll move into mechanical design, which involves more of the prototyping, CADing, choosing what to build stuff out of, and then how to build stuff to be the strongest and most effective part it can be. So let's just start with a simple definition, which we're going to use a lot today, is strategic design. So strategic design is not the same as mechanical design. And a big part of that is it's often mislabeled to be mechanical design when they're not the same thing at all. So strategic design is basically the process of setting priorities to define the robot's actions throughout the game. And that really helps us optimize the robot building process and determine what we're going to do before how we do it. And the main goal of having a strategic design process before mechanical design is it really helps us avoid tunnel vision as we start building our robots, so that we know what we want to do before we get stuck on like, I want to do this instead of doing this. And then it really opens our perspectives and just gives us a larger opportunity to make a better robot in the end.
Right, so into our game analysis, we start off day one at kickoff with a whole team meeting. Everyone is required to show up so everyone understands the game, and we all split up the manual piece by piece and read together. And from there, we go into the nitty-gritty stuff. You know, the how you score points, how you get these points, and some of the rules as well. And basically, we break down the game into specific parts on where we can score points on the field, what is a better option to score points, what's more point dense, how do you get ranking points, and from this, we can start to develop a list on what are the areas of the game that are more important to us? And based on that, we can start to develop the idea of how we want to play the game as a team. This is really important to us in the fact that without an understanding of how we want to play the game, we don't understand how we want to build a robot, because after all, the robot is playing the game, and without an understanding of what we want to do on the field, we can't really get our points where we need them to be.
Yeah, and a big part of that is genuinely understanding the game before you try and build a robot to play the game, because if you don't, you're going to mess something up. So from game analysis, we move into something we like to call the units of robot. And the units of robot is basically where we decide how we want to allocate our resources to different subsystems on the robot so that we can most effectively meet the goals that we assign during kickoff. So here we can see that each little green cube sort of represents one, I guess you can call like a resource, and then we have to split it among 5 different subsystems of our robot. So generally there's like 2 like polar ways you can do this. You can either spend everything and like on a couple of them and then make those 3 really, really good, or you can distribute them evenly among all 5 and then have all 5 be sort of average. And it really depends on the game which one you want to do, but generally we always aim to try and focus on a couple things instead of trying to make everything at once, because what happens when you focus on too many things at once is you overwhelm yourself, and honestly you end up just making everything kind of not the best it could be. So it's often better to just stick to one thing and focus on that one thing, and so you can make it the best.
And
product.
then having one over the other, one setup over the other, isn't actually or necessarily the better option. It depends on the team. Like I said, back to kickoff and back to day one, it's about what your team wants to do, what your team wants to accomplish over the season. If your team is confident that they can get all tasks done effectively with the amount of resources that you have, then sure, by all means, go for it. But if you don't think that you can do all 5, or you don't want to do all tasks, then doing just a couple of them is a pretty good thing as well. It all depends on what your resources are. And in fact, this season itself, we actually had to make that cutoff with the mechanism that we had to do with the color wheel. We felt like it wasn't as effective as we decided it to be, especially since we saw gameplay of teams not really using the color wheel in actual matches. So when it came time to cut off weight on a robot, we were like, you know what? It's not something that's scoring a lot of points on the field, so it's something we can definitely do without. And it's a decision that we had to make later on. But it's all about what you feel is necessary.
Yeah, ultimately, you can't really say that one is better than the other. It all depends on the team, and it depends on the game. So it's really important that you sit down with your team and decide which side you want to choose, or if you want to have a mix of both. From there, we move on to our priority list, which Sid can talk about more.
Yeah, so again, back to kickoff from day one, we start with what we want to do, a hierarchy of robot attributes as it's stated here. We create a plan of what we want to accomplish on the field. For example, in the case of infinite recharge, we wanted to make sure we had a shooter bot because shooting points was essentially the bulk of the gameplay. But we also wanted to be able to hang on the bar and during endgame, and also cross over through the middle. We sort of developed this priority list as a team and together to work around how we're going to plan our season now. Because we essentially prototype and we design based on our priority list. We go through our list saying, oh, driving is at the top of the list, so we're going to get that off first. We're going to make sure that this task is done and it's the best that we can be. And then we're going to go down the list into our needs and our wants, right? So we organize what we need and then what we want and then what's a good to have. And then from there, we start prototyping and we start building. And that kind of just gives us a structure for the season, because without a structure, we're kind of just going around and developing. And sure, maybe sometimes it will work, but having a structure and having a plan is 9 times out of 10 always the better option.
Yeah. And just being able to look at everything you want to have done and just go down in order, it really, really helps organize your season. And without it, I don't think we could be nearly as successful as we are. So a part of analyzing the game comes from analyzing individual game pieces. And a part of that is looking at how you want to interact with game pieces and using the features of the game pieces as an advantage. So obviously with this year's game, we had basically dodgeballs. And there's a bunch of different ways you can interact with dodgeballs. You could obviously, just have claws that hold them, or like a roller intake system that can intake them. But and then like using different characteristics of the ball to help intake it is really, really important. Like another factor we saw this year was that they had a lot of friction between different balls. So if we wanted to, it'd be a lot easier to intake balls using wheels compared to using claws, because of the fact that they have so much friction and we can use them to try and intake them. But at the same time, you don't want to get too carried away with this. Obviously, they also have little holes to fill air in them in case they get deflated. You don't want to try and spend your entire game shoving the needle in the hole to carry the ball around. So you need to make sure that you can balance between using game pieces in the ways that they were designed, but also looking for other ways that you can use the game pieces to most effectively move them. And another part of that is looking at how you can score game pieces.
My bad.
Another part of this is looking at how you can score game pieces. Yeah, looking how you can score game pieces, because you always want to look for the most efficient way to score. Obviously, there's different ways to score points every year, and then going through all the ways you can score and then really deciding which one is the best helps you a lot in making sure that you can make the most efficient plays every time.
Yeah, I was going to give another example with the game pieces. Was this year we figured out that they're really they could be compressed down to pancake level. We wanted to make sure that we could design our mechanisms to account for that, which is why we kind of used Polygon in our system, which we'll show you later on with our renders, in order to make sure that we could control the ball in an efficient way, but also account for the tolerance of the ball and the fact that it could also move. We did a similar thing last year with noticing that the end game platforms were essentially flat pieces of wood, and we designed our climber around that last year with a suction cup climb, or a vacuum climb rather. where we can plop a plate down with a seal on the platform, and then you can use that to gain leverage and then lift ourselves up. So game piece analysis is a huge part of designing our priority list and seeing how we can possibly prototype and design mechanisms around it.
Yeah, I like the pancake example a lot because I know a lot of teams this year actually compress balls so that they were able to store them and shoot them a lot easier. So from here we move on to prototyping, and prototyping is basically developing models that function exactly the same as the final mechanism, but not really look the best or are the safest or just generally last the longest. It's more about just getting ideas down and trying to figure out the best way to do something using any resources we have available.
Yeah, so prototyping is actually a very long process, or not a long process, but a very tedious process on our team. We typically spend almost all of week 1 and 2 of the build season just getting as many ideas out as possible. We have a saying that's saying no idea is a bad idea, because sometimes the weirdest ideas actually end up being the best ones, or not necessarily the best ones, but the ones that work best for our team. So what we do is we get every idea out. We figure out a way to use the materials that we have in our lab to make a basic model that will get the essence of the idea down, but not necessarily be in the best possible way it could be, because we want to iterate on models later on after we decide what is the best option for our team. So we use any materials that we have available to our lab or in the kit that's provided with us, and then we just figure out what we like about each prototype and what we don't, and then we work from there.
Yeah. Well, we can show an example of something we prototyped a lot near the end of the presentation, because we have a lot of renders that we can reference and show how things really developed and evolved over the season. So from here, after the prototyping, you really move on to something we like to call Crayola CAD. It's basically just the concept of getting rough ideas down somewhere where we can visualize them really accurately. And obviously you can sketch on paper, but being able to have actual dimensions helps a lot with that. And here you can see an example from the 2019 game where the large circle in the middle would represent one of the balls from that game, and then the 2 smaller circles on the outside would represent intake wheels. And using a small sketch like this, you're able to get the geometry down for a mechanism that, in this case, intakes balls. And that really just helps you develop further, more complicated ideas without getting mixed up on the basic structure behind it. And a lot of it is based on concepts from prototyping. So you need to use measurements from prototyping or modify measurements based on how well things work. And that's really how you get the basic shape. And then from there, you can make more complicated models and more perfect parts.
So yeah, materials are my bad. So yeah, materials are a big part of our season. In the fact that we want to choose materials that work well together on our robot and what would work best for us. Typically, we like to keep it towards plastics or metals. We use polycarbs for our plastics, which are really flexible, but because they're flexible, they have a much more tolerance. They can bend more easily, and because of this, they often can decrease precision. However, they also do have a decreased amount of weight. So if we're keeping weight in mind, we try to do plastic when it's possible, when it's not necessarily something that has to be really precise, but we can do a plastic to decrease the weight of the material. Aluminum we do for a lot of our bigger and more heftier parts. Examples are our drivetrain, our big mechanisms that require accuracy. Our shooter was another example. It allows for more strength and more rigidity, but it's more difficult to manufacture. Manufacturing aluminums for us have actually been a little easier in later years because we did get a CNC and we also had access to a laser cutter at one of our mentors' workplace. This allowed us to laser cut some of our parts, which allowed us to have more precision with our cutting and better manufactured parts. But these 2 materials are typically the materials that we keep towards as they have worked well for us in the past, and they continue to work well with us in current seasons.
In the topic of materials, a large portion of designing any part is deciding how you're going to slot it to save weight. And generally, there's a lot of ways you can go about this. I think it's pretty standard to say that triangular slots or hexagonal slots, anything that really has some sort of diagonal beam is the most effective way to minimize weight while also trying to keep the strength of the material. But generally, what we see a lot, especially later on in the season, is teams finishing the robots and then realizing that everything weighs way too much. And then they basically just take the biggest drill bit that they can find and they just drill through every single part so that they can minimize weight. And I don't think I have to say that that's bad, but there's a lot of drawbacks to just drilling holes in parts without planning where those holes are going to be or thinking about how it's going to affect the structure of the robot. And the same thing goes for cutting square slots too. Even if you plan out your slots and then cut out square slots to try and save weight, although you do technically can take out the most material using a square slot, you also heavily sacrifice the strength of the material. As you can see, the two members on the top of that beam in the middle right there, those two members become extremely thin once you slot out the entire thing with a massive rectangle. And having triangular slots can take out not as much material, but a pretty similar amount without sacrificing the strength as much. Oh, and a big part of that is planning ahead. So make sure you plan ahead with your weight reduction so that you don't, finish your entire robot and then realize it's 20 pounds overweight. Keep weight in mind as you build your robot and then try to keep everything as light as possible. And generally that'll just give you a better time when you're at the end of the season, you realize you're 5 pounds underweight instead of overweight.
Actually happened to us this season as well. We were a couple of pounds overweight and we were like, well, what can we cut? Because we already did plan ahead. We did slot stuff out. It eventually led us to taking off our color wheel mechanism and then figuring out what else we could save. But, it is what it is at the end of the day. Whatever works for you guys is what you should run with.
Yeah. Cool. So from here, we can talk about examples about how we do things on our team. So this is what we like to call the singulator. It's basically our indexing mechanism on our robot. And it's what takes a bunch of power cells and just throws them in a line for our turret to use easily. And the little front thing at the front is what went through a lot of prototyping at the beginning of the season. Sid, you want to talk about how we prototyped the singulator a bit more?
Yeah, so we actually ended up starting with a cardboard model, if you believe it. So it was all cardboard. We were actually debating between using a salad bowl, which is kind of a circle that spins the ball around and then spits it out into a straight line, and this. This actually ended up being what we chose to use as we figured it would work better for us in the time that we were given. We wanted to make sure we fit between our 6-week build season, even without the bag day this year, because we felt like even though we could do a salad bowl as well as we can, we wanted to get everything done in a timely manner and stay to schedule because we do actually like anodizing our parts, which is the black tint that you see on our aluminum parts, which is why we chose this. It actually allows us to take up to 5 balls, which is the game max, and put them in, jam them in as well as we can, and then it'll spit them out one at a time into our ball tower, which will allow us to shoot from really, really efficiently. And we actually tested the jamming too. We tested putting 5-6 balls in there and seeing how well it would hold up. And we used that test over the course of the season with every single iteration of our design. We figured out, well, what works, what doesn't work, what can we improve based on jamming the maximum amount of balls into the singulator at once.
This is our power cell intake. This is an example of a part that took a lot of rough CAD so that we could get the measurements and stuff right. So basically, when we designed our power cell intake, we wanted it to be able to reach underneath the trench during autom and grab those 2 extra balls from across the trench without having to be small and driving underneath it or having to go around. And it led us to this design. And the way we came up with this design is by sketching out where the ball was and then sketching out the shape of our robot in one part file in SolidWorks. And then from there, using sketches to basically rough out measurements for where the ball needs to be relative to a robot and then where the intake of the robot needs to be compared to the trench. And then it really just allows us to visualize everything. And then from those sketches, we were able to extrude parts, and then we could add stuff like the gearbox and then the gearbox and the lightning pattern and then polycord and everything later on once we were actually started designing things.
And on top of that, for the power cell intake, what we also designed was, if you notice, there's a pretty wide gap right there for the power cell intake. And what we wanted to do was actually, again, load up the maximum amount of balls at any given time, because we have this idea that we used on 1923, which is touch it, own it, where when you touch a game piece on a field, you want to make sure that you own that piece, that you are the sole controller of that piece, which is what we try to do here. We realized that this is a game that had the ability to control more than one game piece at a time, and it hasn't been that way in a couple of years. So we were like, you know what, maybe we can widen the intake, see if we can manage to control more balls at once and therefore decrease our cycle times, but also make sure that it's accurate enough that if we had any amount of balls, it would ensure that we always have control of them at any given time as well, which is why we have this wide design that allows us to maximize balls and maximize control as well.
Yeah, so here's just a quick render of our robot. We just want to use this render to show an example of planning out where everything is going to go before you design parts, because you don't really want to design mechanisms for a robot and then realize that nothing fits well with each other. You really want to be able to design everything sort of as like, I was going to say like as like brothers, you know, they like grow up together and then they just fit well with each other and then they don't interfere with each other when they're being used. And just thinking about everything as like developing at the same time really helps you design a robot that is well packaged and also make sure that you can have access to everything whenever it needs to be fixed, because stuff needs to be fixed all the time.
Yeah, for example, on this robot, something that we did by thinking ahead from the beginning of the season was an issue that we have for like every single season on 1923 is our e-board has no space at all. We always have to jam it in somehow. And we were like, you know what, let's be unique this year. Let's figure out a way we can, you know, figure out how to put it on where it's not going to be in the way of any other parts. So if you notice on the render, you don't actually see the e-board, and the reason for that is because it's underneath the robot, right? So we actually put the belly pan on the top part of the drivetrain, so we have that space for the e-board to go underneath, and that way it's really easy to change out parts and have repairs on the e-board in case there's something that does go wrong, because all you have to do is flip over the robot, and our electrical team can just, you know, work with it. But it also allows mechanical to just, you know, have all the parts on top and there's nothing in the way. So we had all that space to work with.
Yeah, flipping the robot onto its back gives you access to both the electrical system and all of the mechanical systems at the same time. So you can access the entire, everything on the robot without having two people fighting for the same amount of space like we had in previous seasons. Cool. So that was our presentation, and we're good for questions.
Yeah, and I think if you guys have questions for Arnav and Sid more specifically about the 1923 design process or specific designs and prototyping, I see two in the question box already. You can actually put them into the Q&A box. I really hope I'm getting this right to the 2468 people. You can put them in the Q&A box and we will get to them at the end. And I believe that that means it's my turn, which is interesting and fun. I don't know how to follow them because they're much better at this stuff than I am. But Arnav, I do need to steal the screen from you. Thank you. Yeah, I think there's a couple of really interesting questions about specific design stuff. So if you have anything on the 1923 design side, please make sure you ask in that Q&A box. Like I said, what I find so funny and interesting, and I mean that in a genuine way, is that everything they're saying, oh, you don't want to do that, is because it's something that we have done on 1923 in the past, when I was a student, or in previous seasons, like, oh, you don't want to do it that way. And I'm like, oh, we did it that way. But it is something that I think transitions well between the two topics, because one of the things that I get asked about most frequently with Team 1923 is how does your team structure? Our team is very large. So how do you learn? And all the things in this presentation are essentially from something that we have learned in a previous season to help make a better structure. So for a slight bit of background, Team 1923, the MidKnight Inventors, is actually a 118 student team. We're from 2 high schools inside of the same school district. We started off as 4 students and a couple of our dads in a garage, and we made a ton of design mistakes then that we've learned from, but we were a very, very small team, and through a lot of sort of intentional organization and goal setting with the team, we have sort of adapted to a larger team. And that's something that I get asked a lot of questions about. So I figured I would jump into how we structure our team. The disclaimer that I have, I guess, before I get started would be that this may not work for every single organization. We have an immense amount of privilege, but also sort of different ability to grow and learn from our different opportunities. So if this doesn't work for your team, that's okay. This is not the one and only way to run a large FRC team. So like I said, the MidKnight Inventors, we're celebrating our 15th season this year. We have students from 2 different high schools that collaborate on all of our objectives and projects. They take part in learning opportunities, in training, and in basically every aspect of their FRC team. It's interesting, this is a little bit stolen from how we describe the team to parents and families interested in the program. So when I say a mentor-based program, working with professional adults from the community, just for a sense of scale, we have 118 students and about 5 or 6 dedicated adults. So we have a very strong balance of student leadership doing a lot of work and adults on the sidelines going, yeah, absolutely, no problem. Like, let me figure out how to do that paperwork for you or make it happen. But whatever it is that you guys want to do is what we'll do. And whatever it is you're not jazzed about, I'm not going to push you. So one of the things we focus on as a team is outreach and community service. We make sure that our students are not just building robots. We are also mentoring FIRST LEGO League and FIRST Tech Challenge teams. We're doing community service programs. We host events. And that's something that I think is important because it's how our team has grown. We started our first feeder FIRST LEGO League teams in 2007 at our middle schools. And we've had an explosive growth of FIRST LEGO League as well as FIRST Tech Challenge in our area, not just because of our team, but also just because the programs start to grow. But we attribute a lot of our current team size to having a full family of programs. That's something that I do want to touch on a little bit, but I'd like to talk about here. So the way that the FRC team is structured is that we have 2 branches, essentially, the robot branch and the sustainability branch. Now, these look like your average sub-teams, right? You've got mechanical, you've got CAD, you've got electrical, programming, and strategy. And then on the sustainability side, you've got business and awards and outreach. None of this is all that surprising from the perspective of FRC sort of team management. We have sub-teams. But the interesting thing, I think, on our end is because we have so many students, we actually have a leadership of about 20, I think we're 26 or 27 student leaders this year. So we have on the robot branch, we have a mechanical captain, an electrical captain, and a programming captain, and then directors in mechanical, electrical, programming, strategy, CAD, all under those captains. And then you sort of have the general student body of the team, which is really cool. It's definitely different for how certain teams work, but it has worked for us because, like I said, we have a pretty small number of adults on the team. And it has helped us immensely to have this like small army or essentially another FRC team's worth of experienced leadership who can then teach. And I'll get into that in just a second. Same thing on the sustainability side. We have a fundraising captain, we have an outreach and events captain, we have an awards and media captain, and then each of those have their own directors as well. And the reason we love having so many leaders is because they run a program in the fall called MidKnight U. That is a weekly seminar series every single Monday night. I'll get into our team schedule a little bit. Every Monday night, we do a topic in the fall. So when you're first joining the team, it's a lot about, what is FIRST? What are FIRST programs? Interestingly enough, I don't know the actual stat this year, but my students do. Somewhere between 20 and 30% of the incoming class for the FRC team this year have prior FIRST experience, whether that's FIRST LEGO League or FIRST Tech Challenge. Somewhere in there, and I'm sure they're going to get it faster than I can. But we, like I said, because we have established FIRST programs, the intro to FIRST is typically interesting, but a lot of them have done it already. Kind of a broader look at what the WWP robotics program is. That's our school district. And then each sub-team gets an entire night where it's just teach new MidKnight Inventors exactly what it is that you do. What does electrical do? What kind of tools do they work with? Electrical actually is a great example to pick on because they bring in all the control system components and then they start to do electrical work even in that first week. And the idea is, if you're bringing in each year, it's probably between 30 and 40 new students. We have a pretty even balance across the grades, but some years are bigger new classes, then we graduate more seniors, and it sort of eventually evens out. But the new students they definitely haven't seen FRC before, but they may never have even seen FIRST before. So we try to start truly from the ground up in terms of what does a FIRST team entail. And again, like we've said, we've learned a lot from mistakes. One of the things I see, not only that our team used to do, but also I see other teams do a lot, is they will start meetings in the fall and just sort of like get to know each other, which is great. And then January hits and we all get a game, and someone's like, oh, could we put this crazy electrical thing on it? Well, that's not quite how this control system works, right? So it helps us because it lets us create the system around what an FRC build looks like, or what an FRC season looks like, starting in September and October. And again, for that entire fall semester, each sub-team has their own sort of component of time. They either get their own Monday night, or in the case of CAD and programming, they get their own course structure, which if you wanted to, let's say you join the team, you go to MidKnight U and you learn that the CAD sub-team is where you 3D model the robot, and you get to get super granular and all this cool design stuff. And you're like, man, I really want to learn how to CAD. Well, then Arnav, who just gave you a nice presentation on design, is our CAD director, and Arnav has a separate night of several weeks of CAD classes where we teach SolidWorks. So it's sort of a 101, an intro to the program. It is not like, yes, I've done this one Monday night and now I know everything there is to know about mechanical design. But the idea is that it gives every student on the team, as they come into the team, a taste of what they might like. So maybe you joined robotics because you really like coding, but you had no idea there was this whole other electrical and sensor system that you could even work with. So now you're like, maybe I'm not going to join programming. Maybe I'll join electrical. It lets the students decide what they want to do before they get to January. And then in December, we sort of have a, pick your sub-teams. Each 1923 student takes part in both a technical and a non-technical sub-team, at least one. So, maybe you're super into building, you're mechanical, but you are also going to help with some outreach and some fundraising. I'll get into that in a moment, actually. The biggest expectation that I have, and this is a question I get a lot with how large the program is how do you get students to work? And I say, I don't ask anybody to do anything. We set project deadlines, but I'm not saying you go do that process. We are a self-motivated program. I will open every single possible door for you. It is up to you to step through. And I'm seeing on my students' faces that they are so tired of hearing that as leaders. Every single leader, every single mentor on the team is there to design systems for which a new student can contribute. Our jobs are to teach and to help others join in on the team, but I am never going to take a freshman and drag them to the workbench and sit them down in front of the drivetrain, because if they don't want to do that, they don't have to. Like I said, we open every door and it's up for you to step through. And that sounds very harsh. And of course, if a student is kind of interested and on the fringes and isn't quite there, that's where a leader or a mentor will identify, like, oh, that person really is jazzed about the drivetrain. Like, come on, come help with me. Like, that's a very different situation versus someone who's just like, nah, I'm not going to do robotics. Okay, don't. It is hard for a small mentor group and even for the larger leader group to reel somebody in that doesn't want to take part. Of course, robotics is open to everyone, and we will, again, provide every opportunity. But the way that you manage so many people is that at a certain point, there are going to be people who aren't interested, and that is okay. They can choose not to do that thing. I just want to touch a little bit on our FIRST family of programs. We have all K through 12 robotics programs in our school district as well as in our community. Right now, we have 22 FIRST LEGO League junior teams that we either start, mentor, or somehow affiliated with. We have 20 FIRST LEGO League teams that we work with. Some of those are school-based teams and some of them are community. We have 2 First Tech Challenge teams, the Midnight Magic and the Midnight Nova. All of those programs at some point started out of the FRC program, whether it was a student going to coach a team, or we run a workshop series where, let's say you're a parent and you really want to start a First Legacy team, you don't know where to start, we'll help you with that. We sort of have our own little version of a coach's manual where we will teach the right people how to run those teams. We tend not to administrate teams ourselves just because it is a much heavier effort on the adults to administrate the teams, but we will absolutely train any parent in our area or even not in our area on how to do that, and then we will mentor and support those teams. And then of course, when we get to FRC, we have the 1 team with 2 high schools. One of the questions I get a lot is, if you have so many students, why don't you do 2 teams? That is because we don't have enough grown-ups. I will be fully honest on that. I cannot be in 2 places at once. I can't work at both schools. None of us can. If that superpower existed, I think we'd all be doing a lot more. But we actually only started as one of the high school teams, and the other high school South, was like, hey, we want to do FRC. And actually, the students who were in charge of the team at the time, I was one of them, went to those students and said, hey, please don't start your own FRC team, because we're just going to be competing. We're in the same town, the same school district, we're competing for resources, and that doesn't make a lick of sense. So let's do 1 team together. And that's how we became the 1 group. Expectations. This is sort of interesting. All of this information is in our team handbook, which is a very, very long document that I won't scroll through because we will be here all night. But this is sort of the high level stuff on the team handbook. Anybody can join the team. It's a part of being in the school. It's a part of being in the district. Anyone can join the student activity, the MidKnight Inventors or WWP Robotics. If one of those people signing on wants to travel to competitions, we have a couple expectations. It's on the screen, but what it boils down to is you're engaged with the team. Obviously, the numbers and the percents are going to be different for every single group, but we want to see that you've joined the team, you're interested in the team, and you are making yourself useful. And at that point, yeah, come with us to our district. Come with us to district championship. The thing that I do want to point out, though, is that we ask for activity on both sides of the team. So just being all about build is not going to cut it. Actually, both of these guys who presented earlier are both obviously on our robot branch leadership, but they're also super involved in our event planning and our outreach and our fundraising. We don't say that you have to do equal amounts or crazy amounts of both things, but we do say help out. Make yourself useful on both sides of the team, because without one, the other cannot exist. Without the business team, can't build a robot because you can't pay for parts. Without a robot, the outreach team has nothing to show off in the parade, right? We're all sort of one unit, and we make sure that everybody has just a little bit of experience in every space. We obviously up those expectations if someone wants to be a leader in the future. So, young Sid was once not a leader, and he had to look at this and say, have I been to competitions? Have I participated in meetings and build sessions? Have I helped out with the awards? Have I helped out with media? How can we sort of, work through this together? And so, sorry, Sid, I didn't mean to pick on you. I see you. The young Sid, or young Arnav, would have looked at this and said, how much work have I done? Now, we have a lot of students who do a lot of other activities and are involved in a million other things and are going crazy over their grades and all sorts of stuff. We never want this to be prohibitive. And when students have other things, like, actually, I will pick on you again, Sid. Sid plays a sport. And so as a build director, all I ask is that he tells me what days he's not coming because he has a game. I don't say, well, you have 2 games this week, so obviously you don't meet your travel requirements. No. As long as we're communicative and we figure it out, it makes it happen. We're not trying to build a brick wall here. We're just trying to set an expectation that you are active and engaged with the team. So I know there is a question in the Q&A box about sort of our meeting schedule and how that works. So I'll gloss through this very quickly because I also know that I have a apparently genetic knack for talking over time. In the fall semester, we meet once a week. We have these Monday night, midnight U meetings. Well, they're not even nights anymore. They're straight after school. We changed it used to be Monday nights. It's Monday after school now. I'm going to call them Monday night meetings for the rest of my life, just like I'm always going to call it ship day. Monday night meetings, again, it's that high level overview, and then certain groups, for example, programming in CAD, as well as our mechanical, all have separate training opportunities. So obviously you can't get shop certified in one night, so we kind of space those out over the weeks. The only other two, I can't control my computer apparently. The only other two things that we do is we have a mock kickoff in the fall. We pick a game from 5 years ago, 8 years ago, whatever, something these students haven't seen, and we go through that strategic process in detail so that when we get to kickoff on in the Saturday in January, whatever, January 4th, January 9th, we can go through the harder conversations about design trade-offs without having to stop and say, we might make this trade-off because da-da-da. So we will already have gone through this much longer version of what does that decision-making process look like, so that on actual kickoff, we can just bang through decisions really quickly. And then in the fall, we also host a state qualifier for FLL. This comes up, again, I stole my slides right out of our parent info meeting, but it's important because we do ask students and families to partake if they can, just because it helps us run the team. In the spring semester, if you're watching this, you're probably affiliated with FRC, you're aware that is robot build season. And then our competitions are in March and April. And then I gloss over postseason, but late spring and throughout the summer, we try to do outreach, host events, as well as recruit for the team and sort of teach these younger groups. I know I'm talking too much, so I will keep moving. Our Monday meetings are an hour after school. The cool thing is our school district actually provides a bus between the two high schools. So if you go to South after school, you take a bus to North and it'll take you right to robotics. But in build season, we use that same time frame as an all hands team meeting. There we go. Words are hard. So obviously in build season, you're probably not learning what is mechanical design or how does the electrical system work. We use that essentially as the stand-up meeting for the week. Every single student comes in on those Monday nights and says, hey, mechanical is doing this, electrical is doing this, CAD is doing this. Here's what we accomplished. Here's what we didn't get to on our task list. And here's the plan for next week, as well as like, hey, we need to buy this thing, or we, sort of work. I just realized it said attendance is still counted. I told you I stole these slides from my parent meeting. See your handbook for more information. The reason I think that's really important is because we split up our build season evenings. So if you're on the electrical sub team, you might not be there every single day. Obviously, our shop is not big enough, to fit 118 people at once. So we make sure we space that out. Our robot work groups are alternating. So again, we're trying to work around students who have other commitments in their school day or in their week. You essentially choose whether you want to come in on a set of a weekday and a weekend or the other weekday and weekend. So right now it's Tuesday, Saturday, or Wednesday, Friday. So if you're, say, on the CAD sub team, the first week of build season, we say, yep, CAD, come in for your days. And that means, I'm on the Wednesday, Friday group. I come in Wednesdays and Fridays. We'll actually make that call on those Monday catch-up meetings. So as we have all been through many build seasons, hey, early on, we really need mechanical, we need CAD. And then as the robot starts to come together, mechanical comes in less, electrical comes in more. And then it's really together, electrical starts coming in less, programming starts coming in more. We rotate through those throughout the weeks of build. Let me see. And this is one that I made a fake, I have to preface this for a second. The biggest question I have about that, because we do have the expectation that if you are I lost my train. Nope. Oh, words are hard, guys. If you're this big team and you're, we have this expectation for travel, and you say you have to come to 60% of build sessions that you're called in for. And again, that's where that 60% really means what you are called in for. So I don't say out of every single hour that we've ever been in the shop, you have to be there for 60% of it. We say, you know, hey, we called in electrical for 10 hours over the last 2 weeks. You have to have come to 6 of them. Someone asked me how I do that, and I had to make a fake version of our hours tracking spreadsheet. Basically, the answer, as this all boils down to, like, how do you organize such a big team, is just like, I have a really big spreadsheet. We ask for, like I said, particular percentages of hours and outreach and all sorts of stuff. This is a fake build season. This is the weekdays of week 1 and the weekends of week 1, and so on and so on and so on. How many hours is a given student called in for their sub team, and how many did they actually show up for? And that's how I have a digital version of this that you can play with and put in fake hours and stuff like that, that I need to scrub data from. But as you can see, I made a sort of a fake version with, you know, 118 students, name, first name, last name. That's a resource that I try to make sure, obviously it's pretty specific to us because we have these really weird incidental instructions of how many hours you need to be around. But I find it interesting to look at if you're someone who maintains a team or admins a team that you don't quite know how you're going to track all of this. I tend to shy away from overly digital solutions. They sign in on paper and I write it down and put it in the spreadsheet. So yeah, that's, if there's anybody out there who is very interested in my giant spreadsheet, I will happily share it with you. I'm not sure that it's particularly interesting to every single person watching the stream or watching the video later, but if you have any questions, you can always contact us. I will actually put my email sort of in the chat, and we'll put it in the description box for the video because our website's currently down, but we do have a Google Drive for all of our team resources, our handbook, our leadership structure, tons and tons of information that we share with the FIRST community. And also I'll put my email out there. So if anybody has specific questions post-show or anytime ever, you are more than welcome to ask me. With that though, I think that I will allow our wonderful hosts here from Team Appreciate to give us some Q&A.
So thank you so much for an awesome set of presentations. Next, we'll be moving on to the Q&A section. If you have any questions, please make sure to drop them in the Q&A box. We might have too many questions than we have time for, but we'll try our best to get to everybody's questions. Our first one is from chat. What kind of data do you gather from your prototypes? How do you log/sort that data during a busy build season?
Yeah, so I can actually speak a little bit more to this. Basically, when we take prototypes, when we design them, we always take videos of everything we do, and we organize them in Google Drive. And then we kind of look over that video on our own time, or sometimes we drop in Discord. We're like, hey, take a look at this, say what you think. But before every meeting, before every build session, we have a pre-cap and a recap at the end. The pre-cap is mainly what we want to get done, what we have currently, and what we want to do on that to make it, the next step. The recap is what did we get done, and what can we do next time we meet. We also do this again at the Monday meetings and every other meeting that we meet. We say, look what we got done, what can we do better, and from there we kind of decide, well, we felt like this model was good, but we can make it better by doing X, Y, Z, or this model was not good, what can we do to make it better, or maybe we want to scrap the idea as a whole. So yeah, we kind of just go over all our ideas as a whole together, and sometimes we also have smaller group discussions as well.
Yeah, and especially we like to take a lot of video. So every time we test anything, we take videos so that we can look over it with groups that weren't there, or analyze everything in slow motion, things like that, so that we can really understand how things are working and then try to alter things even in the slightest ways possible, just to make sure that they work the best we possibly can.
Awesome, thank you. Another question from chat. What is the reason behind using 4 wheels on each side as compared to the more traditional 6?
So the reason we used 4 wheels per side of our robot for a total of 8 wheels compared to 6-wheel drive is mainly for stability. So obviously we're shooting balls this year, and our goal was to shoot all 5 of those balls as quickly as possible. And obviously when you're shooting balls that fast and that far, and 5 of them at once too, it puts a lot of strain on the balance of your robot. So it like tips it over to one side. And a big And having 8 wheels in total really helped us balance our robot more and make sure that we don't put too much pressure on either end of our robot and sort of keep everything leveled out more. It also helped with the bars in the middle of the field too, because those bars are like 2 inches wide and like 1 inch tall. And having wheels spaced out in the way that we designed them helped us drive over those bars without having our robot wobble back and forth too much and potentially tip over.
So our next question is also from chat. Can you talk a little bit more about your workshops for parents interested in starting FIRST teams? Are they in person or online? And what kind of engagement do you have from the workshops?
So sure, our workshops for parents, or just sort of general information for our younger programs, so First LEGO League Junior, First LEGO League First Tech Challenge, we have typically run that in an in-person seminar. We usually throughout the year, whenever we do outreach events or online stuff, we have this form that's like, I'm from the local area and I want to do FIRST. And that could be, and it just says like, how old is your kid? Is there a team? We do whatever work we can to connect students and parents to teams. When it comes to starting those teams, right now they're in person, but we're figuring out how to transition them online, probably going to come in handy this summer. The engagement that we see is we get folks in, we teach them how to run their team, and we will help them with every step of the process, from registering to where do I buy shirts, you know, all the little stuff. And then we'll keep a MidKnight Inventor mentor with them. So we tend to see pretty positive team outcomes just because we don't just drop them information and walk away. We try to give them as much information as possible to get their program started and then stay by their side as much as we can.
Awesome, thank you. Another question from chat. How do you create a positive team culture in a large team? Yeah,
so being the large team that we are, you know, figuring out how to make sure everyone works together and has a great experience is one thing that we always have to work hard at. But we do this in a couple different ways, right? We have we make sure that everyone on our team is as included as possible. Example of this is we build 2 robots in order to get as many people to work hands-on on the robot at any given time. But we also make sure that we use our leaders to help include people. A conversation that we actually had with our leaders this year was, how can we make the newer students on our team feel more included, and how can we make sure that they are learning as much as they want to and doing as much as they want to as well. And we said that essentially what we want to do on our team is that we want to make sure the leader's job is to teach but not do, essentially. And by this we mean that, again, it's up to the student's job to figure out how much they want to pour into the team. But when they do want to work, you know, the leaders aren't doing everything on the team because they solely know how to do it. The more that they teach the students how to do stuff and how to work on the robot. So that not only do we ensure our future for our team, but also that people understand what STEM is and what robotics is, and we're essentially just extending, you know, FIRST core ideals.
Yeah, our job as leaders is to make sure that every person has the best experience possible, and really following up on that goal is how we make sure that every person has the best experience possible.
Awesome, thank you. Our next question is also from chat. How do you conduct design reviews? Who is involved and when do you do them?
So our team is heavily CAD focused. In that, I mean, we like to CAD stuff before we build it. And so whenever we conduct design reviews, we'll usually have one person sit down with a laptop in the lab, hook up to the projector and just project the robot into the wall and have everybody look through everything and make sure everything is up to where we want it to be. We'll typically try to have every single person in that day with us. And then on top of that, we'll also have the Monday meeting after or the Monday meeting before, depending on how time works out at the specific design review session. We like to also recap everything we go over during the design review to make sure that the entire team is fully understanding of what we're doing with the robot, where the robot is right now, what changes we need to make, why stuff isn't working, and that sort of thing. So we can really keep 118 people in the loop at all time and make sure that nobody gets left behind.
Awesome. Another question from chat. Is most of your FIRST outreach focused within your school or to the wider community?
So I'll let these guys bounce off of this if they want to, but as sort of the school district-ish person, it's a pretty even mix. It depends on the program. We have FIRST LEGO League in our middle schools, but for example, we don't have FIRST LEGO League Junior at a school level. So the different programs kind of each have different needs. As far as the FRC team's activities, it's pretty split between helping out other organizations in the school and helping out other teams that may not be school affiliated. I would say the majority of our FIRST programs are outside of school, but then we also do programs and curriculum work with the school district. So there's going to be a new robotics course at the school next year, for example, and that's not a team, but it's still outreach work. This, again, it's sort of an even mix.
So how do you structure your kickoff and at the beginning of the design process with such a large team?
Yeah, so to design to structure kickoff, like I said earlier about making people feel included, we actually do something called mock kickoff, which is in the last couple of weeks of December. We choose a game that no one's seen for a while, and we kind of just put everyone together. We kind of go over the kickoff process, and that way day one, when an actual kickoff happens, everyone's about to hit the ground running. And then we split up the game manual into bits and pieces so that everyone has a little chunk that they work on their own to have ideas and give ideas out. And from there, we kind of just work together as a team, and everyone spits out ideas that we all write down, and we then discuss over and over and later on.
Yeah, so it comes to dividing up the manual, reading through it really fast, and then making sure that we get all the necessary information out and then share it with the rest of the team.
Yeah, having 118 members is actually a blessing in disguise, in the fact that you can take a large chunk of work and then divide it among all these people, and then everyone will have a small chunk. Well, you get things done faster in a way.
Yeah. Cool.
Awesome. Thank you for your great answers. Unfortunately, we're starting to run out of time, so we're going to be doing some rapid fire questions. The first one is, what is the balance between 9th to 12th graders on your team?
Oh, I can get this one. It's almost dead even this year, but it tends to fluctuate. We'll typically have about 30 or so new students every year. They're not always all 9th graders, but lately we've had just about even grade levels across the team.
How often do you have full team meetings?
We have full team meetings every Monday, and then we have build sessions spread over the rest of the week, except for Thursday and Sunday, so that we can get everything done and then make sure the rest of the team is in communication with everybody else too.
How do you work on CAD, do you work on CAD from home?
So working on CAD is a mix of working in person and working at home. So for small things, nobody really needs to come into the lab to fix the size of a wheel or something. But if you're trying to design something major where we need access to prototyping data or see how things are working, then we try to work in the lab so that we can have access to things like that and then test things out as we design them. But for the most part, we like to keep simple stuff at home, but anything big, we like to do in person at the lab.
How many people are usually in the shop for mentors and students?
We usually like to keep it pretty even between 2 work days. That's why we have the signups in the beginning of the season. But I'd say anywhere between 30 and 40 on a pretty packed day with all the sub-teams in. But it's not usually that packed because not all sub-teams are always called in.
Yeah. And then we usually have anywhere from 3 to 4 mentors in at once to keep track of everybody and make sure everybody's doing productive work.
Are your adults professional mentors?
So the way that works is we have a couple of mentors who are paid by the school as robotics advisors, but that doesn't mean they work for the school full-time. Some of them are teachers. For example, I am not. Most of us have full-time jobs that are not mentoring, but then anybody who, I'm sort of a weird anomaly. Most volunteer mentors who are not paid by the school are full-time employees doing something else. Most school advisors, which there are 3 of them, are just school advisors or are teachers and are also school advisors. And then I sort of sit in the middle in this weird, I work full-time, but also I'm a school advisor.
All right, and then our last question, what grades are your FTC members in?
So in the beginning, we tried to keep it 7th to 8th, but in recent years, we've sort of just let it spread out from 7th grade all the way up to 12th grade. So FTC spans 2 more years than FRC because of age restrictions in FRC.
Great. So thank you so much for your awesome answers, and thank you everyone for coming to First in Focus. We are so glad that you all came tonight, and we hope to see you again. Next week, we will be hosting a show with the 2019 Woody Flowers winner, Ellen Gregory, and Team 3847 Spectrum. Keep an eye out on social media or Chief Delphi to get more information about that. We are also very excited to announce a First Signing Day. Our initiative to celebrate seniors will still be taking place on May 20th. We are officially partnered with FIRST to promote and run this event. Thank you again, everyone, for coming, and stay safe.